Welcome to fourth video on linear integrated circuits, especially triple five timer and its applications. In this video, we shall see the application of triple five timer as a stable multivibrator. Let us first try to understand what is this stable multivibrator. As the name itself indicates that, this circuit does not have a stable state. Output level will keep switching from low to high and high to low continuously. So level will not be stable. It will be high for some time, it will be low for some time. So that will be keep changing continuously. The duration of low and high levels are predefined. So up to what time this will be there in high state and up to what time it will be there in low state is a predefined parameter. This is a circuit diagram and the waveform of an astable multivibrator using 35 timer. Again, the blue colored circuit is a 35 timer, and we have three extra components, that is RA, RB and a capacitor C, which are going to be connected in a particular fashion so that the 555 timer works like a stable multivibrator. So we shall see the working of this stable multivibrator in detail in the coming slides. As it was said that it remains in high state and low state for a predefined time. So these are the two equations which describes the timing of high and low. The TH is given by C into RA plus RB into ln of 2, which is 0.69 C into RA plus RB. Similarly, low time is given by C into RB into ln of 2, which is 0.69 C into RB. So total time of the entire high and low is given by 0.69 into C multiplied by RE plus 2RB. So these are the equations which will specify the on and off time of the output voltage. So we should see the working of the astable multivibrator. So in stage by stage. So let us first consider the voltage of the capacitor is greater than 0, but it is less than VTL. So this capacitor voltage, as you can see, the capacitor is connected to the inverting terminal of first comparator and the non-inverting terminal of this is the first terminal, the non-inverting terminal, the inverting terminal of the second comparator. Since it is capacitor voltage is greater than 0 and it is less than VTL, we can see here since V plus of the comparator 1 is connected to capacitor, its voltage is greater than 0 but it is less than VTL as well as less than VTH. Now you can see we are comparing the V plus of the comparator 1 with respect to VTH because it has to be compared to VTH. As long as V plus of the comparator 1 is less than VTH, so V plus of the comparator 1 is less than VTH, the output voltage will be there in negative saturation, that is 0 volt. So that is V minus is greater than V plus. So as long as the capacitor voltage is less than VTH, the output of the comparator 1 remains in 0. So that's what is happening in the first case, where we have the capacitor voltage is less than VTL, the comparator voltage is 0 here. Just have a look at this. Now this is VTL, but this is less than VTL. When it is less than VTL, we know that V plus is more than V minus here. Actually the the comparator output happens to be VCC. So that's what is mentioned here. V plus is VTL, whereas V minus is less than VTL. So out of these two, V plus is greater than V minus. So naturally output of the comparator happens to be plus VCC. So that's what is VCC here. Now we have a condition for reset it is 0, for set it is 1. RS flip-flop is going to set its output. So output is becoming now high. So as you can see now, when the capacitor voltage is between 0 and VTL, the output is in high state. So this is high. So when Q is high, the Q bar is 0. So the the transistor is off. When transistor is off, the capacitors keep charging through RA and RB towards VCC. I can see it is keep on charging now. So this is keep on charging. So where it is charging at the VCC. The path of charging is RA plus RB. The time constant is RA plus RB into C. We shall see the summary of the same thing. The capacitor voltage is between 0 and VTL. The reset is 0, set is 1. Once set is 1, the output of the final output of the Astable timer is also high. The BJT is off. Now the capacitor is charging towards VCC through RA and RB with the time constant RA plus RB into C. Now the flip-flop is in set mode. Now we know that the capacitors keep charging towards VCC if it exceeds VTL. So this is exceeded VTL, but it is less than VTH. So we have this condition now. Capacitor voltage is greater than VTL, but it is less than VTH. So that's what is written here. VTL less than VC less than VTH. VTL less than VC is nothing but VC greater than VTL. Now capacitor voltage is more than VTL, but it is still less than VTH. So that's what is written here. The first comparator, the capacitor voltage is still less than VTH. So, but this is V minus is VTH. The output of the first comparator here, V minus is greater than V plus. So naturally the output voltage is minus V sat, which is 0 volts. Coming to second comparator, since V plus is VTL. So that's what is V plus is VTL. The V minus is greater than VTL. So V minus is greater than V plus. Actually the output of the second comparator is becoming 0 volt. Now we can see earlier this was VCC, Q was VCC, and this is 0. Now the reset and set voltages are becoming 0, 0. So when reset and set are 0, 0, we know that in the truth table of RS flip-flop, it remains in the previous state. The previous state was actually a VCC for the Q. So that's what is VCC. Now it remains to be there in VCC for this particular condition, meaning as the capacitor is charging from VTL towards VCC between VTL and VTH, the output remains in high state. Now let us see what happens if the capacitor voltage. Okay, let us see the summary of this again. So we have set and reset output voltages 0, 0. So this is a condition when capacitor voltage is more than VTL, but it is less than VTH. So under such case, reset and set are 0, 0, meaning that the output remains in the previous state, the BJT is off, the capacitor is still charging towards VCC through RA and RB with a time constant RA plus RB into C. Why it is RA plus RB is because it is charging through these two resistors. This capacitor is charging through both the resistors RA and RB. Now let us see what happens if the capacitor voltage is greater than VTH. Now this is the case now. So we have a condition where the capacitor voltage is, this is the case where the capacitor voltage is greater than VTH. Now this is VC greater than VTH. Now we know that in the first comparator, if V plus is greater than V minus, so that's what the condition now is. Now as soon as the capacitor voltage exceeds VTH, this V plus exceeds V minus of the first comparator, naturally the output of first comparator becomes VCC, so that's what is here. Now looking at the second comparator output, since V plus is at VTL always, this V minus is greater than VTL. So because since this V minus is greater than VTH, it will be certainly greater than VTL. So we have this V minus greater than V plus. So we have this condition, V minus is greater than V plus. In such case, the second comparator output becomes 0. Now we have a condition, reset is high, set is 0. So we are forced to reset the output. Now the output is becoming 0. As soon as the output becomes 0, this Q bar becomes VCC, which will be a base drive for this transistor, which will turn on the transistor and make the capacitor discharge through RB to ground. So that's what is happening. As soon as the output becomes 0, Q bar becomes 1 because these two are complement. When this is VCC, it will turn on the MOS transistor Q1. It allows the capacitor to discharge through RB, and so you can see now it is discharging through RB transistor and it is going to ground. So this will get discharged as soon as the capacitor voltage exceeds VTH. You can see here, this is what is happening. So as soon as it tries to exceed VTH, now the capacitor is started discharging. So that's what is shown here. So in this region, as soon as it enters, it is greater than VTH, it starts discharging. So let us see the summary of this particular. So when VC is greater than VTH, the reset is 1, set is 0, it resets the output. Once it resets the output, BJT is on. Now timing capacitor discharges towards 0 volt through RB and the BJT. Through RB and BJT with a time constant RB into C. Now why it is RB into C is because it is discharging through RB as well as BJT, but here it is simply written as RB into BJT, neglecting the on resistance of the BJT, that is RB on is very small compared to RB. Now you can see this was in the previous stage, it was slightly exceeded VTH, now it started discharging. Now we shall see what happens if the capacitor voltage is less than VTH but it is more than VTH, that is during this time of the capacitor voltage. So as we know that since the VC has gone below VTH, so the V plus of first comparator is less than VTH, whereas V minus is at VTH, the output of the first comparator becomes 0. Now second comparator voltage is also, output voltage is also 0. So since it is 0, 0, we know that flip-flop remains in the previous state. So the previous state was 0, it continues to be there in 0 state. So capacitor is still discharging. This is a summary. Reset and set are 0, 0. The output voltage is 0 in the previous state. So BJT is on, the capacitors keep on discharging towards 0 through RB with a time constant RB into C. We are neglecting the on resistance of BJT because it is small compared to RB. Now let us see what happens if it is the capacitor voltage is, because we know that in the previous case it was going towards 0 volt. So on its journey towards 0 volt, it will cross VTL. Suppose it goes below VTL, as you can see here. This is going below VTL. If it is going below VTL, this comparator will going to change its state from 0 to VCC. Now it is VCC now. As soon as it becomes VCC, this will become 1. When it is 1, it will going to set the output. When it is set, this is Q bar is 0. When Q bar is 0, the transistor is off. The transistor is off means the capacitor again starts charging. Now you can see the capacitor again starts charging once the capacitor voltage goes below VTL. That's what is the summary over here. So it is when reset is 0, when set becomes 1, the output is 1, the BJT is off, the capacitor is again charging towards VCC through RA and RB with a time constant RA plus RB into C. So flip-flop is in set condition. So this is a whole summary of all different stages which you can easily understand. So we have written the status of R and S, the output, the BJT, and the capacitor discharger.